with increment operation. Design a stack that supports increment operations on its elements. Implement the custom stack class. Custom stack int max size initializes the object with max size, which is the maximum number of elements in the stack. Push adds x to the top of the stack if it hasn't reached max size. Pop returns the top of the stack, or pops and returns the top of the stack, or -1 if the stack is empty. And increment increments the bottom k value elements of the stack by val. If there are less than k elements in the stack, increment all the elements in the stack. Easy peasy, I think. I don't know. I'm lying. So don't usually see a LeetCode problem like this where you have to do multiple like functions, but I don't know. I think it's kind of cool. So I could be totally wrong about how this should work, but I'm thinking, maybe I don't see why it would be inefficient or anything to just basically make this like a modified array. Let's see. We're gonna say self dot stack or vals is an empty, starts as an empty array, and self dot max size equals max size. All right, so that's how our array is going to be. Now for push, we're just going to edit vals as long as it doesn't affect max size. So we're going to say if self vals, if the length of that is less than max size, self max size, then we're going to return, we're going to, let's see, if it is less than that, if it hasn't reached it, then we can push it. So we'll say self vals dot append x. Okay. For pop, we're going to keep the same logic, but we're going to make sure that's greater than 0. And if it's not greater than 0, then we return -1. Otherwise, we return the last value in the stack, which should be, I think it's -1 index. Yes, that's right. Okay, last item on the list. Okay, yep. -1 index loops back around. So we're going to say self.vals I think we had to hold on to it because when we get rid of it, we need to return it but also get rid of it. So we hold on to the value in a variable, we get rid of that value, and then we return that value. Okay, now we remove. Let's see, I'm sorry, I'm going to have to remember how the remove works. It's been a minute. Okay, well, you could just use pop. Yeah. Could we just use pop? I think so. And then increment. We just need to iterate through self.vals and make sure that we don't run out of elements or run out of k. So we'll say I equals 0 while I is less than k and I is less than length of self.vals. It's basically say, okay, make sure that we either stop when we run out of elements or when we go through the bottom k elements. Self.vals I plus equals val. Right? I think so. That should be it. Oh, no, that can't be it because there's an endless loop. We forgot, we made the classic blunder. I plus equals 1. There we go. Come on, work, please. There we go. Ooh, kind of ugly. Let's look at some other solutions since mine was not good. Oh, interesting. Okay, so they use the values. This person, instead of editing the length of the array every time, which I think could take longer, they just initialized it with a certain set of values so that the pointers stay the same, I believe. Okay, and then they hold on to a variable for the top. Okay, makes sense. It's one of those problems I think where it's like very small differences make all the difference in the world. Big change in, like 10 milliseconds made a difference between me being at like the 50 percentile or something. I don't know. But yeah, not the best solution, but I got it done real quick. I'm still getting back into it, still getting the rust out, but thank you for watching. I appreciate you. Have a great day.